Hello students, myself Rakesh Yadav representing Sandipani Higher Secondary School Rajoda. I am your maths teacher. Chapter 5th we are discussing continuity. Our question number 7 of exercise 5.1. Question number 7 of NCERT. Question is, find all points of discontinuity of f where f is defined by f of x is equal to, firstly it is mod of x plus 3 if x is less than or equal to minus 3, and this f of x is equal to minus 2x if minus 3 is less than x is less than 3. F of x is equal to 6x plus 2 if x is greater than or equal to 3. Means we are having 2 points where we have to discuss the continuity. Why we are discussing continuity? Yet in question it is given that we have to find discontinuity point. Because continuity test we know already. After applying continuity test, if it is continuous, then there will be no point of discontinuity, and if it is having discontinuity, then it is very clear that LHL or RHL is not equal to f of that particular point. So at x is equal to minus 3 we are discussing first of all. At x is equal to minus 3, continuity test. It is well clear here that there are 2 points where we have to discuss the continuity at minus 3 and at 3, because minus 3 is having LHL part, this f of minus 3 is also this only, f of minus 3 plus h, that is called RHL, is given discussed here in this part of the function, which is minus 2x, and less than 3, here it is minus 3 up to here, it is minus 3, and for 3 minus means LHL of 3, that is this part minus 2x, and f of 3 is this part 6x plus 2, and f of 3 plus means greater than 3, also this part. So we have to discuss the continuity at 2 points, at minus 3 and at 3. There are 2 points to discuss the continuity. So at x is equal to minus 3 we are discussing first of all LHL, left hand limit, that is equal to limit x tends to minus 3 minus f of x, that is equal to limit h tends to 0 f of minus 3 minus h. It will be equal to, because here we are changing the limit, h tends to 0, that is why we have to write it minus 3 minus h. Limit h tends to 0. Now we have to replace x of that function with this value minus 3 minus h. Our minus 3 minus part means LHL part is this, because minus 3 less than minus 3 is only LHL. That is why we have to put the value of x here in this part. So in place of x we are writing now minus 3 minus h. So it will be minus 3 minus h mod plus 3. On solving limit, as you know very well that modulus value is always, the value which is mentioned in mod is always become positive when we take it out from the modulus sign. Then it will be first of all in modulus only minus 3 minus 0, because value of h is 0, that we have to put here because we are solving the limit, plus 3. So now this will become minus 3, that is become positive 3 here, because minus 3 mod, no need to write it again. If you want to write it, you may write minus 3 mod plus 3. then it will be 3 plus 3, that is equal to 6. It is our LHL. Now, let us discuss f of minus 3. F of minus 3 is equal to mod of minus 3 plus 3, because for equal to 3 minus 3 also this value of function is applicable. In place of x we have to write directly minus 3 because equal to sign is here only. So, minus 3 mod is again 3 and here it is plus 3. So, 3 plus 3 is 6. Now, RHL, that is right hand side of the number line we can say for minus 3. So, x is here greater than minus 3 because minus 3 is less than x, means x is greater than minus 3. So, in RHL we have to apply minus 2x. In RHL we have to apply minus 2x of this function. Limit x tends to minus 3 plus f of x, that is equal to limit h tends to 0 f of minus 3 plus h, that is equal to limit h tends to 0 mod of minus 3 plus h in 2 into because this is only the part where you have to remember this, that you should not have to apply it here now, because for greater than minus 3 this will be applicable. So, it will be minus 2 into x, that a value of x is minus 3 plus h. So, here it is on solving limit it will become, if we solve this limit now, so it will be minus 2 into minus 3. Why is it so? Because value of h is 0 here. That value if we put here, then minus 3 plus 0 will be minus 3 only. So, minus 2 into minus 3 will become positive 6. So, we can say that LHL is also 6, f of minus 3 is also 6, RHL is also 6, because LHL is equal to f of minus 3 is equal to RHL. Now, this part is over. Here at minus 3 there is no point of discontinuity at minus 3 if we are discussing. Now, this is only not the part of this function. So, we have to proceed it with plus 3 now. So, for that, first of all here we have to mention it is continuous at x is equal to minus 3. So, here continuity only, not discontinuity. Yet our question is remaining because we have to discuss it on 3 also. So, at x is equal to 3, we have to again apply continuity test, that is necessary to apply it, continuity test at x is equal to 3. So, at x is equal to 3, continuity test LHL, limit x tends to 3 minus, means less than 3, x is less than 3 here. So, we have to put value of x here now in this function, f of x, that is equal to limit h tends to 0. Now, in place of x we have to write 3 minus h in function, f of 3 minus h, f of 3 minus h, that will be applicable here. So, it will be equal to limit h tends to 0 minus 2 into 3 minus h, this is equal to minus 2 into 3 on solving limit. On solving limit it will be minus 2 into 3, that is equal to minus 6. So, value of LHL is minus 6. So in LHL we have got value minus 2 into 3 on solving limit, because value of h is 0. So minus 2 into 3 is only the remaining part. If we put the value of h 0 here, so minus 2 into 3 is minus 6. Now f of 3, that is equal to, for equal to 3 this will be applicable. So we have to put directly 3 in place of x here. 6 into 3 plus 2, that is equal to 18 plus 2, so it will be equal to 20. Now RHL, remember this, that for LHL it is 3 minus, which is less than 3 part, so it will be applicable here. But for equal to 3 we have to apply the value of x 3 in this part of the function, which is our third part of function, that is known as 6x plus 2 we can say. So in place of x, that's why we have written here 3. So 6 into 3 plus 2. So according to the substituted value, 6 3 is 18 plus 2, that will be 20. So RHL is equal to limit x tends to 3 plus f of x, that is equal to limit h tends to 0 f of 3 plus h. So now this will be applicable again in this part, because for greater than 3 also this function is applicable, which is 6x plus 2. So in place of x we have to substitute 3 plus h here. So limit h tends to 0, 6 into 3 plus h plus 2. So on solving limit, six into 3 plus 0 plus 2. So 6 3 is 18 plus 2, it is equal to 20. Now it is well clear to us that at minus 3 it is continuous, but at 3 LHL is not equal to f of 3 and f of 3 is equal to RHL. One more thing now I want to tell you, this will come in your higher classes courses, that it is left hand discontinuous but right hand continuous function, because right hand limit is equal to f of 3. But we are not discussing here left hand continuity or right hand continuity, we are just discussing discontinuity. So it is discontinuous function because LHL is not equal to f of 3 but it is equal to RHL. Therefore f of x is discontinuous at x is equal to 3. See now our question, find all points of discontinuity of f, where f is defined by f of x is equal to mod of x plus 3 if x is less than or equal to minus 3, minus 2x, that is if minus 3 is less than x is less than 3, and 6x plus 2 if x is greater than or equal to 3. So we can conclude here that 3 is not that point at which it is discontinuous, minus 3 is not that point where it is discontinuous, at minus 3 it is continuous, but at 3 it is discontinuous. So this question is over. Here again one question of NCERT exercise 5.1, question number 11. This is also, in this question also we have to discuss points of discontinuity only, but here only one point is there where we have to discuss, that is 2. So at x is equal to 2, continuity test. LHL, that is equal to limit x tends to 2 minus f of x, because at 2 we are discussing, so we have to apply here limit x tends to 2 minus f of x, which is equal to limit h tends to 0 f of 2 minus h here. Remember one more thing, that you please don't apply this 2 minus here minus 2, because this is afterwards applicable. So 2 minus, sometimes such type of mistakes can occur. So you should have to remember this thing always, that it is 2 minus means 2 minus, you will not have to apply that minus sign here, you have to apply this minus sign here always, if it is 2 minus. If it is minus 2 minus, then you will have to apply here minus. So limit h tends to 0 f of 2 minus h means for less than 2, this is only the function's part. So we have to put value of x 2 minus h in this part of the function, which is x cube minus 3. So limit h tends to 0 2 minus h whole cube minus 3, on solving limit it will become 2 minus 0 whole cube minus 3, that is equal to 8 minus 3, so it will be 5. This is LHL. Now f of 2. So for equal to 2 also, this function is considerable, because for equal to 2 it is defined by this part of the function, which is x cube minus 3. So we have to put in place of x 2 directly here in x cube minus 3. So it will be 2 cube minus 3, that is equal to 8 minus 3, and this is equal to 5. Now we have to take RHL. It is f of 2. Now at RHL we have to mention it, limit x tends to 2 plus. Why 2 plus? Because at 2, at x is equal to 2 only we are applying continuity test. So limit x tends to 2 plus f of x, that is equal to limit h tends to 0. For 2 plus means for greater than 2, we have to put this part in function of x, where it is given as x square plus 2, because in front of x square plus 1, sorry, x square plus 1, because in front of x square plus 1 only it is mentioned that x is greater than 2. So first of all we have to write here f of 2 plus h. So in place of x I am putting 2 plus h in this part of the function, which is x square plus 1. So limit h tends to 0 2 plus h whole square plus 1. On solving limit, if we solve the limit for this part, then it will be 2 plus 0 whole square plus 1, which is equal to 2 square is 4 plus 1, so it will be 5. So it is well clear that what are the values. Here in LHL it is 5, in f of 2 it is 5, in RHL again it is 5. So because LHL is equal to f of 5 is equal to RHL, therefore f of x is having no point of discontinuity. So in this part of question, LHL, f of 2 and RHL, all the values are 3. That's why we may write LHL is equal to f of 5 is equal to RHL. Means having no point of discontinuity here. You may mention directly that no point of discontinuity. Again, now question number 12 we are discussing. Find all points of discontinuity of f, where f is defined by f of x is equal to x raised to the power 10 minus 1 if x is less than or equal to 1, and it is equal to f of x is equal to x square if x is greater than 1. So at x is equal to 1, we are applying continuity test. LHL, that is equal to limit x tends to 1 minus f of x. So it will be equal to limit h tends to 0 f of 1 minus h less than 1. For less than 1, it is defined by x raised to the power 10 minus 1. So we have to put this part of the function here. Means in place of x, I am writing here 1 minus h now. So it will be limit h tends to 0 1 minus h whole raised to the power 10 minus 1. On solving limit, it will be 1 minus 0 whole raised to the power 10 minus 1. 1 into 1 into 1 10 times, it is 1 only. So it will be 1 minus 1, that is equal to 0. Now f of 1 means for equal to 1, again this part is applicable. So in place of x, we may write directly 1. So it will be 1 raised to the power 10 minus 1, that is equal to 1 minus 1, and it will be 0. So f of 1 is 0. Now for RHL, limit x tends to 1 plus f of x. So for greater than 1, it is clearly mentioned in the function that function will be x square now. Function's value f of x will be x square now. So we have to apply value of x here. It will be limit h tends to 0 f of 1 plus h, it is equal to limit h tends to 0 1 plus h whole square. This is only applicable. So on solving limit, this will become 1 plus 0 whole square, or we can say 1 because square of 1 is 1. Here it is 0, f of 1 is also 0, but RHL is 1. So LHL is equal to f of 1, but it is not equal to RHL. It is well clear, because 0 is equal to 0, but it is not equal to 1. So LHL is equal to f of 1, but it is not equal to RHL. Therefore, function is, or f of x, function f of x is discontinuous at x is equal to 1. At the defined point, it is discontinuous, and our main aim is to find the point of discontinuity only. So this question is over. Again one more question, but now the pattern of the question is changed. In previous question it was written that find all the points of discontinuity. But here it is asked, is the function defined by f of x is equal to x plus 5 x minus 5 if x plus 5 when x is less than or equal to 1. But in case of x minus 5 it is x where x is greater than 1. So it is defined in two parts, this function. For x is less than or equal to 1 it is x plus 5, for x is greater than 1 it is x minus 5, and here we have to find continuity. Means basically I want to tell you one and the very simple thing, that you will have to always apply the continuity test there. If the continuity test is valid, means LHL is equal to f of that particular point is equal to RHL, then at that particular point the function is said to be continuous, and if it is not continuous then you will have to mention that it is discontinuous. So in case of discontinuity, if you are getting continuous, then you will have to mention there is no point of continuity. But in case if it is not continuous at a particular point, then you will have to mention that this function is not continuous or discontinuous at that particular point. Suppose that particular point is A, then at x is equal to A, it will be discontinuous if LHL or either of the LHL or RHL is not equal to that function of A. So now this question is the function defined by f of x is equal to x plus 5 if x is less than or equal to 1, and f of x is equal to x minus 5 if x is greater than 1. So now at x is equal to 1, continuity test. At x is equal to 1, we are applying continuity test. Here LHL, that is equal to limit x tends to 1 minus f of x. At x is less than 1, this part of the function is applicable, which is x plus 5, because x is less than 1 mentioned here only. So we have to put the value of x as 1 minus h here. So limit h tends to 0, if we are changing the limit, then this function will become function of 1 minus h. Function of x will become function of 1 minus h. Limit h tends to 0. Here we have to apply the value x 1 minus h, or we have to substitute the value 1 minus h in place of x. So it will be 1 minus h plus 5. On solving limit, it will be 1 minus 0 plus 5, that is equal to 1 plus 5, or we can say 6. At x is equal to 1. So equal to sign is not mentioned here, it is also mentioned in that part of the function, which is our first part. So at x is equal to 1, we can say f of x or f of 1 directly, because at x is equal to 1 we have already mentioned. So no need to write here again x is equal to 1. F of 1 is equal to 1 plus 5, that is equal to 6. Now RHL, limit x tends to 1 plus f of x, means 1 plus means for greater than 1. Again I am showing you on the number line. Repetitively I have told it in my early lectures, but now also I am telling. Suppose it is 1, means 1 minus is LHL, this is left hand side, so it is LHL, and at 1 plus it is RHL. And at 1 we have to put value 1 only directly. So it will be limit h tends to 0, f of 1 plus h Now we have to put 1 plus h in this part of the function for greater than 1. So in place of x, I am writing here 1 plus h, or I am substituting the value of x as 1 plus h. So limit h tends to 0, 1 plus h minus 5 on solving limit it is equal to 1 plus 0 minus 5, that is equal to 1 minus 5, and it is equal to minus 4. Here it is 6, here it is also 6, but here it is minus 4. So LHL is equal to f of 1, but it is not equal to RHL. Therefore, f of x is not continuous at x is equal to 1. See, one more thing I want to tell you, that in which manner the question is asked. We have to answer the question in that particular manner always. It is asked here, is the function defined by this?